Show you one way to use ACI, the Advanced Cyber Infrastructure, the cluster computing resources at Penn State. These are run by the Institute for Computational and Data Sciences, ICDS. URL is ics.psu.edu because they recently changed their name from the Institute of Cyber Sciences. You should be aware of ICDS, their homepage and mailing list, links to a lot of interesting talks. You see one here on wearables and this data science community. To use ACI, you need an account. You can click here or click here to get the form and request an account. You need to name a principal investigator, which if you're on an active research project with a faculty member who is on ACI, you should name them. If your advisor's on, you should name them. Otherwise, SoDA students can feel free to name me. There's a lot of information on how to use it. If we click through to the user's guide, there are two types of nodes on ACI. There's ACI B and ACI I. ACI B is for batch jobs. That is, we write a script, submit it, and the script waits until there's a machine it can run on, and then it runs in sequence what you ask it to run. It keeps a log if you ask it to, and so on. And then you go and monitor it, and when it's done, you go get your answers. We're going to use ACI I. I stands for interactive, so we can do it live. The task we're going to do is small enough that it would be okay to log into ACI B, which generally doesn't have any wait time, and run it there. It's not great behavior. They want interactive work to be done on ACI I. And also, if you run something that does take longer, there's some length of job. I think it used to be a half hour. It may be much shorter now, where they will stop the job if it's running on ACI B without the permission. Okay, so you want to go to portal.aci.ics.psu.edu, the ICS ACI portal. You'll have to log in through web access. And I imagine if you don't have an account, you don't get logged in. So you'll just have to watch me, I guess. We're going to go to Interactive Apps and ask for an ACI Interactive Desktop. This is a form for us to request a computer that will do our work on. Desktop environment GNOME 2 is fine. Allocation open is our only option. Number of hours usually defaults to 2. I put it to 1 because we don't need much time. Usually defaults to ACI B. I changed it to ACI I. Asked it to send me an email when session starts, when we have the computer available, have the node available. And so I'll launch and we'll wait. I'll pause the recording while we do. Back. That took less time than I took to check. I waited a couple of minutes and it was already ready. It may have been almost instantaneous. Okay, so we'll launch in a new tab. And we get this desktop. Looks very much like a Windows machine. And we can use this just like a normal, conventional graphical interface to our file system. We're going to interact with it, though, through terminal. This is at the top. We can print working directory, PWD. Let me make this a little bigger. Okay, that's better. PWD's print working directory. See, we're in my home directory, BLM24. obviously that would be yours. When you start, you're going to have a couple of folders there. I'm not sure exactly which ones will all be there. bin will be there. Work is where you will normally keep your files. I'm going to go and do it in Scratch, which the Scratch folder is an area that is effectively unlimited in storage for a very short period of time, and it gets wiped every day or week as necessary. So you can use it to give yourself, if you need to store something temporarily that's beyond your limits. We're going to be downloading that fairly big file, so I'm just going to do this all in Scratch. So we're going to change directory, cd Scratch, and we're going to list ls what files are there. And I could have done this up here as well. We've got michelexercise.shell and michelexercise.r. These have exactly the commands that are in the notebook. The R notebook that runs the bash internally, we're just going to run everything in bash. I can show you what what these files look like. Okay, so this, I'm going to need to edit this. Okay, I've commented out those so I didn't download them more than I needed to, but I'm going to fix that here in a second. All the commands, unlike these commands in the notebook, I've put the word time in front of the command time, which is tells it to kick out how long it took to run. The core command is the next word. So this goes and gets our 1 gram file, that big zipped file. This unzips it. This goes and gets the total counts file. This is explained in the notebook. This is grep, regular expression searching. We're going to grep that big Google file for the lines that begin with the year 1870, 1880, 1890 through 1999, and put those into a file, micheldata.txt. I'm going to sort that, and then this cleans up that tab delimited total counts file. TR is transliterate, transcribe, transliterate, replace tab characters with new line characters in this file, and put the result into this file, totalcounts.txt. So now we have it in a more normal into line format. We're going to use the tail command, which says give us the last, by default, 5 lines or 10 lines of the file. We're going to tell it to give us the last, all of the last lines, but starting after skipping the first 2. That's those 2 blank lines in totalcounts.txt, and put that in totalcounts.csv. Now we've got it in, it's actually tab delimited, not comma delimited. And then we tell it to load R. I'm loading a particular version because I know it works. And then we're going to have it execute the R script, michelexercise.r. Look at that. These are exactly as in the notebook. This is just loads some tidyverse stuff, loads the data files, merges, calculates the new fraction, and then plots our figures, stores them in PDFs. I'll leave the detailed explanation to the R notebook. I said I wanted to edit Michel exercise.shell, so let's see what we have as editors. We'll use this gedit, and we'll open Michel exercise.shell. I'll edit out those comments, save it, close that up. Okay, so again, we have these two files here. Now we've got a third, which is an old copy, a copy of the pre-edit version. Shell, that's in case you want to undo it. You have a certain limited power to undo. And we're going to run the shell script, which itself runs the R script. So to do that, it's a bash script, so we're going to bash Michel exercise.shell. So it's connecting and downloading that big gzip file, which it did in 8 seconds. It unzipped it. Now it's finding the engrams. It's doing the grep command, which I think is the most time-consuming one. It took 16 seconds. And all the rest of it took 5 seconds. And you can see in our directory now we have the files we downloaded, including that 1.4 gigabyte unzipped file, and the files we made along the way. And it created these PDFs, which if we look at are our figures. Oops. It's our totals. That's our replication of what was in the original. And this is our half-life replication of the inset. There's another version of the half-life. But all of that is in the notebook. So that's it. That's how we do that.